Hello, welcome to 2.1b quadratic functions. So this one is saying write the standard form of the equation of the parabola whose vertex is 1, 2 and passes through the point 3, -6. So it's important to note that vertex is that h, k form, and if it's passing through a point, we know that's our x and our y. So we remember that we were given the equation f of x equals a times x minus h squared plus k for standard form. And so now all that we have to do is just substitute these values in, and then we can actually solve through for that value of a, because we weren't given that. So we know x and y. Another name for f of x is y, because that would also be f of 3. We can just plug all of these values in. So f of x and y are synonymous, they're the same thing. So -6 equals a, we don't know that yet, times, instead of x we can use the value 3 for our point, minus h is 1 squared plus k is 2. So far we've just substituted our values in. Now we're going to go ahead and simplify. 3 minus 1 is 2 squared plus 2. So we get -6 equals a times 4 plus 2. So -6 is 4a plus 2. We subtract our 2 to both sides. -6 minus 2 is -8. We divide by 4. And a is going to be -2. So now that we have this value of -2, we can substitute it back in for a. And so then we will actually have our actual equation. So we have f of x equals a is -2 times x minus our h value was 1 squared plus our k value was 2. And we now have our equation in standard form, ready to go. Awesome. So now the next thing we're talking about is finding minimum and maximum values. So finding the highest point or the lowest point of a graph of a quadratic. So by completing the square of this function, we can actually get this formula that they gave to us. So they actually gave that to us. They solved it for us. They did all the yucky math. Thank you, text. So we have a times x plus b over 2a squared plus c times c minus b squared over 4a. That's our standard form if we have our a, b, and c values, if we don't have our vertex. So our vertex form is -b over 2a, and this just means whatever we plug in, whatever we get for that x value, we plug in to the function to get the y value there. So this just says consider the function with the vertex -b over 2a. We plug that in to get the y value. If a is greater than 0, it's going to have a minimum, because if we have a positive parabola, it's going to be at a minimum. So this just means positive function gives a minimum. And it says if a is less than 0, it's going to be a maximum. And so that's just saying if we have a negative parabola, it's going to be a maximum, because that's the highest point. So this is a max. This is a min. I know that it's kind of like a lot of weird vocabulary there, but all that it's saying is this, and that -b over 2a gives us the x value of whatever point our max or our minimum is. Okay, so the next thing that it says the path of the baseball is given by this function, where f of x is the height of the baseball in feet, and x is the horizontal distance from home plate. What is the maximum height reached by the ball? Well, we know our maximum point is the -b over 2a, and then f of -b over 2a plugged in. So let's see, do we know what a, b, and c are here? We should. So we have -0.0032 x squared plus x plus 3. This is our a value. Our b value is imaginary in front of that x, it's a 1, and our c value is our 3. So if we wanted to find our maximum height, all that we have to do is find the x value and then plug it in. X is -b over 2a. So we go -b is 1 over 2a, -0.0032. And we can type this straight into our calculator here. So we go -1 over 2 times -0.0032. Just a reminder, make sure if you're doing something in the denominator that you plug parentheses in around it so that it doesn't get mixed up there. So the x value is 156.25. So if we actually want to find the maximum, what do we have to do to find this y value? We just plug it into the equation, right? So we're going to take this and we're going to plug it in for x here. So we say negative 0.0032 times 156.25 squared plus 1 times 156.25 plus 3. 81.125 feet. So after we plug that in, that is our maximum. Maximum. Yahoo! If we wanted to actually graph this to see what's going on, we could plug it in negative 0.0032 x squared plus x plus 3, not minus 3. Pull up the graph. My graphing window is like kind of funky right now, but we should still be able to potentially see it. If not, we can change our zoom. Let's change our zoom. Well, we know this is going to be really big, so gotta wait. I hit zoom standard, but that's not gonna work because we know we're going to be going up to 80s. In fact, could just go to our window. Let's make our y maximum bigger than our maximum. We'll make it 100. And we'll make our x go, we know the maximum's at 156. We'll go to 200. See what this looks like. Should be able to see a little bit of that curve there. Excellent. So if we calculate our maximum, second calculate maximum, we can also get this value. We do need to know how to do it algebraically. So we go to the left, and then we also go to the right of the maximum. And we get exactly what we predicted. So that point is 156 right there, and our y value comes up to the 81.25. Okay, last question here. Path of the diver is approximated by this equation where y is the height in feet and x is the horizontal distance from the end of the diving board. What is the maximum height? So how do we find maximum? Negative b over 2a, and then plug it in. So negative b is 24 over 9, all over 2a, negative 4 over 9. Let's plug this in so that it doesn't have to be messy. So negative 24 over 9 over 2 times negative 4 over 9. So I've got extra parentheses so that my denominator knows to divide. So we have 3 for x. And so now if I want to find the maximum, I'm going to find what f of 3 is. I'm going to plug it in to the equation. Negative 4 over 9 times 3 squared plus 24 over 9 times 3 plus 12. We just type it in. See my calculator? Negative 4 over 9 times 3 squared. Oops, should have finished my parentheses there. 3 squared plus 24 over 9 times 3 plus 12 is 16. So our height is 16 feet. And we're done.